All right, here we have continuous compounding interest. So some banks use continuous compounding where the compounding periods increase infinitely. The compounding interest every trillionth of a second, every quadrillionth of a second, etc. So it's just always being increased. Now the formula for this is pretty easy. If you remember before, when we had n times per year, this was the formula we used. A equals P times 1 plus R over N to the NT. But now for continuous compounding, it's just A equals P e to the RT. And it's going to be that R is actually supposed to be up here. So that kind of is a mistake. It's P e to the RT. So somehow it didn't go up there. And the way to remember this is PERT, P-E-R-T, PERT. Okay. And so that's how we're going to do it. And now E is just a function on our calculator, the exponential. P is principal. Again, rate is a decimal. T is in time. And so if we're going to do this, let's look at an example here. Find the balance in account after 5 years, subject to, well, in this one, they want us to do it quarterly and continuously. So quarterly, remember that's n is equal to 4, and continuous, that's the PE to the RT. So we're going to do it two different ways. First way, A equals, and now our principal is 10,000 times 1 plus our rate is 0.019, and we're doing quarterly again, so it's just 4 and it's raised to the power 4 times, and it's 5 years. And we'll get that value, and we'll plug that in our calculator. And while we're over there, we'll also do the other one. Now, our principal on this one is 10,000. And now it's times e to the RT, so it's 0.019 times 5. And so now we'll have those two things we can type in our calculator and get our values out. So let's go back over here. All right, so now we're doing $10,000. And then it's times, and we have 1 plus, and we're doing a 0.019 divided by 4 raised to the power, and we're doing it for 5 years, so 4 times 5. So our first problem is $10,994.12. Now our second problem will have 10,000, and now we're doing E. So E is going to be this button here, and it's RT, so it's going to be rate is 0.019, and it's over 5 years. And so we get $10,996.59. Now notice this one was compounded quarterly, this one was compounded continuously. We made a little over $2.47 or something like that on the second one extra. And so that's how you can see the more times you compound it per year, the more money you're going to make. So continuous is the best you can get. And so that's what we'd have. So again, this one was $10,994.12. And this one was $10,996.59. And if you did it every month, that would make it a little closer to the second one, it'd be higher than this one, so it'd be in between them. And if you only did it once per year, it would be a little less than that. And so that's kind of how you can see that the more times per year you can get it to compound, the better off you'll be as far as your money goes. All right. So planning for the future with compound interest. So what we can do is we can take our formula here and we can solve for P. And what we do then is we just divide both sides by the thing that was on the other side, the 1 plus R over N to the NT. So we know what we want in the future. We know our rate. We know the number of times it's compounded, and we know how long. And so then we can say, well, how much do we need to put in to get to that amount? Now, when we're doing this, we're going to always want to round up because if we don't round up on these, then you're not going to have enough money. It'll be too little. So no matter what, you're going to round up on when you're planning for future values. So that's one kind of a key thing. Even if it's less than our thing, we're going to round up to the next higher number. All right, so let's look at an example. So how much money should be deposited today, our principal, in an account that earns 1.5% compounded semi-annually so that it will accumulate to $10,000 in 8 years? All right, so we can do this, again, our equation is principal is equal to A over 1 plus R over N to the NT. So now we just plug everything in here. So principal is going to be equal to, well, we want it to be 10,000 in the future. And it's going to be 1 plus, and we're getting 0.015. Semi-annually, that's 2 times. And then it's 2 times, and it's in 8 years. So we have 8. And so the principal now is going to be, go back to our calculator. And so we're going to have here 10,000 divided by, and we want to put this in parentheses, and it's going to be a 1 plus 0.015 divided by 2, and that's to the power 2 times 8. And that gives us $8,873.18. Now this one's nice because it would round up automatically, but if it had been 1772, you would still round it to the 18 because with this you always want to have more money than because if you don't put it enough, you won't have enough money in your future value. And we could check that if you wanted to. What you do is you plug it back into the equation and see if you did it not rounding up, what would you get? So what did we have again? It was what, $8,873.18. So that's what we need to put in today to get out $10,000 in 8 years, compounded semi-annually at 1.5%. Okay. All right. So let's stop there and we'll come back some more with the time value of money.